Particulate or continuous?
Particle.
Yes. So why you are taking so long? Okay. Next question. Okay. Who is going to tell me? Okay, we have only two guys. Okay. Jeba. So Jeba, what is the size of particles?
Particles are very small, which we cannot see through our naked eyes.
Yes, very good. Okay. So Adil, do particles have space between them?
Yes.
Okay. And Jeba, like particles continuously move or they are still?
No, they continuously move.
Okay, great. Okay, I think you people revised it. Okay, good one. Okay, so basically in the previous class, we today we'll be making notes. Okay, so I'll just share you how you are going to make notes. See, the notes which you are going to make, they are not going to be something, you are not going to copy the book. Okay, so notes will be something for 1 or 2 pages, not more than that, because it's a revision thing. Okay, so we'll be making notes along with whatever we are studying. It will be something a quick notes as well. And I'll just share you few pics as well, how you can make notes, because notes are something a revision part, right? It's not something you are not going to copy each and every line. So you are going to make as, or like you can say precise notes. Okay, nothing to write, just copy and paste, nothing to do copy and paste. Everything you are going to write in precise way. Clear?
Yes,
Yes.
ma'am.
Okay. So I think you wrote the chapter and there you wrote what does matter. You wrote the this five panch tattva, right?
Yes.
Yes. Okay.
Yes, ma'am.
Then after that, we will do like this. Like this is your notebook, right? We will do like this. We will do hashtag for every heading, and after that we'll write few points. Okay. So for now you'll write physical nature of matter. Hashtag physical nature of matter. Okay. And after that you'll write first matters is made up of particles, and in bracket you will write particulate nature. Okay. And second you will write, okay, do second and just write physical nature, just write particulate nature of sorry, matters is made up of particles, and in bracket particulate nature. And second will be size of the particles is very small. Okay, size of the particles is very small. Size of particles are small.
Excuse me, ma'am. And second point, what we have to write actually.
Just write size of the particles is very small. Okay.
Thank you, ma'am.
Yeah, size of these particles is very small. Done?
Yes, ma'am. Done.
Okay.
Yes.
Okay. Then you'll write characteristics of particles of matter. Okay. Okay. So first you'll write characteristics particles of matter have space between them. Okay. Done. First one.
Yes, ma'am. Done.
Yes.
Second, particles of matter are continuously moving. Okay, students, I'll just share you few things. Like as you can see, these are basically the precise. I can understand, you cannot understand them. But I'm just giving you a hint how you're going to make your notes. Of course, you are not going to make like this. You are going to write one by one. So because notes are not the copy paste of your book, right? So as you can see, it is like chapter, first matter, then panchtantra, then nature of matter, particulate nature, and made up of small particles. Similarly, what is characteristics of particles? First, space between them, continuously moving. Then you are going to write about kinetic energy, and like this is how you are going to make your notes. Clear? In 2 or 3 page, it will be something summarized. Your entire chapter will be there in your 2 or 3 page. Fine.
Yes, ma'am.
Okay.
So second, particles of matter are continuously moving. Okay, this one you wrote, and after that you'll write particles. You'll write the experiment. They possess what we call kinetic energy, and as the temperature rises, particles move faster. Okay, or you can draw it like this. That okay. So you just write it down. Particles of matter are continuously moving. That is, just don't write. Just write they possess what we call kinetic energy, or they possess kinetic energy. And after that, write kinetic energy increases with when temperature increases. If you want to write it like this, short form you can, or you can write it like this as well. As the temperature rises, particulate moves faster because kinetic energy increases, and because of this, particles move faster. Clear? So, what you are going to, how you are going to make your notes? First, you will write this, that particles of matters are continuously moving, and then you will write they are made up of, like they have kinetic energy, right? They possess kinetic energy. This particle possesses kinetic energy, and kinetic energy increases. This is a sign of increase, right? The arrow increases because of this temper, like when it increase, when temperature increase, and because of this, what happens? Particles move faster. Particles move faster. Clear?
Yes.
Okay. Just quickly write it down. Done? Students, once you are done, you can let me know. That ma'am, yes, we are done.
Yes.
Okay. Zeba?
Yes, ma'am.
Okay, done?
No, ma'am. Actually, I'm
Okay,
writing.
write it down.
Last one.
Yeah, not a problem. Take your time, but make sure that you are making your notes in very precise way or in a very good way. Because these are the one which will be helping you.
Done, ma'am.
Okay. Now, after this, you'll write hashtag diffusion. Okay. So, what is diffusion? Intermixing of particles of two different types of matter on their own. This is very important. On their own. Okay. Is called diffusion. Clear? So, you'll write hashtag diffusion. And after this, you'll write from here that intermixing of particles of two different types of matter. Just remember, it's not same matters. It is two different matters. For example, one is pencil and one is pen. Two different matter particles of pencil and particles of pen. They are intermixing on their own, and that is known as diffusion. Okay. Just don't write like before, like you have written the second point. After that, only just give it a just give it a dot and just write diffusion and underline it and write the definition. Because after this, you have to write third point as well, na, for particles.
I'm done.
Okay. And Jeba, let me know once you are done.
Yes, ma'am. I'm done.
Okay. Now, third one, particles of matter attract each other. Okay. So after this, you like particles of matter have force acting between them. Okay. This force keeps the particles together. First, you'll write third point. This is your third point. Okay. That particles of matter attract each other, and the particles of matters, they have force acting between them, and because of this, they keep together. Like they are always together.
Done, ma'am.
Okay.
Yeah, I'm done.
Okay. Good. Okay. So basically now we have few questions which we'll be solving, like orally we'll be doing. Okay. And in case if you feel like that, yeah, ma'am, like we need to discuss more things, then we'll discuss on that. Okay. So which of the following are matters? Okay. So this is the very first question and you already know, right? So who's going to tell me?
Mummy.
Okay.
Chair, air, almonds, yeah,
Chair.
lemon,
Okay.
lemon,
Just a minute. Chair and after that?
air,
Okay.
almonds,
Okay.
lemon.
Okay. Lemon. Okay. It is not lemon. It is lemon water.
Yeah, sorry, lemon water.
Okay.
Then smell of perfume.
Smell of perfume.
Yeah,
Okay.
that's
Okay.
it.
Okay. So Adil, do you want to add or do you want to deduct something from this?
Smell of perfume.
Yeah, pardon?
Smell of perfume.
Yes. Smell of perfume is not a matter. Zeba, why? Because you are smelling something, right? How can you say smell don't take place? Like, is a smell has mass or smell has mass or smell is occupying any space?
No.
No, you can say, okay, ma'am, look, this smell sitting over here, like this. Like,
Yeah.
have you ever seen smell sitting or smell walking somewhere or lying on bed? Or you can say, ma'am, come, smell of perfume is sitting over here in my table. Like this, no, na? But chair,
No.
yeah, you can see chair is in a place and a chair is occupying in space and has some mass. Similarly, air have particles. That's why. But smell is not something like that. Air, you can say you can feel air. That okay, air is moving from here and you can feel it, right? Plus, air has some particles. That's why air will be the matter because panchatattva, right? So it was there in air included. That's why you have to include it as a matter. Okay. And almonds, yeah, of course. Lemon water, yeah, of course, but not the smell of perfume. Yeah.
Yes, ma'am.
Okay. Now, second one, give reason of the following observation. The smell of hot sizzling food reaches you several meters away, but you get the smell from cold food. You have but to get the smell from cold food, you have to go close. So, anyone? This we have already discussed in the class itself.
It's because the
Yeah.
food is hot.
So basically, the particles, why this happening? Because the particles of matter, particles of food, they have kinetic, they have the particles, and with the increase in temperature, what happens? The kinetic energy increases, and because kinetic energy is increasing, the particles will move faster. But for the cold food, the particles won't because they have less kinetic energy, so particles will be moving slowly, right? So because of that, the smell of sizzling food or you can say hot sizzling food comes to you. But in order to get smell of cold food, you have to go close because particles are moving very slow, right? For example, this is cold food, this is hot food, cold food and hot food. So particles are traveling too fast, but they are very slow, like this. So you are here, the particles reach you. In order to reach here, you have to come closer, right? Got it?
Yes, ma'am.
Yes.
Okay, students, tell me one thing. Do you want me to help you to write answers, or you can write the answers on your own?
We can write answers by our own.
Okay, what about Adil?
Yes, you can write.
Yeah, you can write, right? But the last one, like the NC exercise one, we will discuss them. I'll just help you to write it down. Okay.
Yes.
And in case if you face like because we have good material, if you are not able to, you can like search. There are good answers available, right? So you can whatever suits you, you can write according. Okay. Next one is a diver is able to cut through the water in swimming pool, but the property of matter does not. Does this observation shows? So who is going to tell me? Okay, so let's just discuss. See, a diver is able to cut through the water. Okay, this is water. This is a person who is going to dive. So he will cut through the water from here itself. He'll just move. He'll swim. But for example, if I throw this person in a box, this is liquid, this is solid, right? If I throw him in a box, he cannot cut that box, right? But in water, in liquid, he can cut it. Why? Because the particles of water are loosely packed, right? They have space between them. So what he will do, he will whatever space, like for example, this is water and this is the particles of water. So basically, wherever he'll be getting the space, he will cutting it down and he'll go. But in solid state, particles are closely packed, right? So he won't be getting any space. But in liquid, you can see that particles have good intermolecular space, right? So because of that intermolecular space, the diver who is going to dive, he is going to cut the water and he is going to swim over there. Clear?
Yes.
Right? Okay. Because for example, this is solid, this is liquid, and this is gas. So solid, the particles are closely packed. Liquid, it is somewhere like this. And gaseous, it is like this. Least one. Okay. So he can easily, cut it out, and that's why he is going to dive it. And now, what are the characteristics of particles of matter? So first characteristics Adil will be telling me.
They are continuously moving.
Okay. Second, Jeba.
They have space between them.
Good. And third, Adil.
They possess kinetic energy.
So what you are going to write? Which they possess kinetic energy, or the particles are continuously moving, right? Clear?
Yes.
Yes.
Yeah, particles are, but if someone will ask you to write the characteristics, you are not going to write particles have kinetic energy. You are going to write that particles of matter are continuously moving, and because of that, they have kinetic energy because they are moving. And in order to move, you need some energy. So that's why they possess kinetic energy, right? Clear?
Yes.
Oh, okay. Now the next one is state of matter. This is going to be very important. Okay, I'll just give you a rough idea about it. States of matter, basically we have three states: solid, liquid, and gas. You are not going to write so much thing like okay, this, that. Two or three things are enough, more than enough. Okay. So now first one is observe different types of matter around it. What are the different states? You already know we have three states: solid, liquid, and gas. Okay. These states of matter arise due to variation in characteristics of the particles. See, if it is solid, of course, it will have different characteristics. If it is liquid, different characteristics. Gas, different characteristics. Right? So now, all of these examples, you can see. Okay, in detail. So we'll just do some, like, we'll start with the solid one. Okay. So you can see all of the above example of solid, we can observe that these have the definite shape. So basically, these are the characteristics: definite shape, distinct boundaries, fixed volume, okay, and negligible compressibility. Compressibility is basically, for example, this is a piece of wood. If you are going to put force over here, right, that you can say negligible. You are not going to compress it. Compress means, for example, with this position, if I am compressing it and now it is becoming like this. So that is compression. Okay, I am putting the pressure over here. You can see it is pressure, PRESS. So compress means I am just putting the force and making it down. But in solid, it is negligible. You cannot compress any solid particle. Okay. So first, what you'll write? You'll write first like the states of matter. Just give a heading, hashtag states of matter. Okay, and after that, first solid state. Okay, let me know once done.
Done, ma'am.
Yes.
Okay, so first I'll tell you the characteristics, then you're going to write. First, you'll write definite shape, distant boundaries. Second, third, fixed volume. Fourth, negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Okay, solid may break under the force, but it is very difficult to change their shape, so they are rigid. Okay, so what are the characteristics? First, this definite shape. Second, distant boundaries. Third, fixed volume. Fourth, negligible compressibility. So you are going to write, you have written first solid state, then you are going to write first, second, like just give it a point and definite shape, distant boundaries like this.
Yeah, I'm there.
Okay.
Done, ma'am.
Okay. After that, you will write one more point. The solid have tendency to maintain their shape when subjected to outside force. For example, you can see rubber band. This is a rubber band. If you stretch it, it will be somewhere like this. But again, once you release that force, they will come to their normal shape, right? So this is the characteristic of solid. That solid have tendency to maintain their shape when subjected to outside force. See, this is rubber band. This is not going to be like this until and unless some outside force is occurring. So once outside, like solid have tendency to maintain their shape when subjected to outside force. So once they are subjected with the outside force, they'll change their shape. But once you are releasing that force, then they'll come back to their shape. Clear?
Yes, ma'am.
Yes.
Done, ma'am.
I'm done too.
Done? Okay. Now basically, okay. So what is happening? Consider the following. That what about a rubber band can be changed its shape on stretching? Is it a solid? So yes, rubber band is solid. So rubber band changes shape under force and regains the shape, same shape when released. Okay, when the force is removed, it excessive force is applied, it breaks. Okay, and next, what about sugar and salt? When kept in different jars, these take the shape of the jar. Are they solid? As I told you, you cannot change the shape of the solid. But like if we'll consider sugar and salt, for example, if I'm keeping in this beaker, the shape of the sugar particles will be like. But if I'm keeping this in this beaker, the shape will be something like this. So, like, are they solid? So you'll get the questions like this. So you are going to mark in your book. You are not going to write it again because everything is written in your book. So the shape of each individual sugar or salt crystal remain fixed. Just remember one thing. See, this is a shape. This is a sugar. For example, this is sugar. So the shape of sugar particles is not changing, right? Of course, when they are collectively taking, if they are taking change, but you cannot change the sugar. If sugar is like this, you cannot make sugar like this, right? The particle of sugar will be like this only, right? So the shape of each individual sugar or salt crystal remain fixed, whether we take it in our hand or put it in a plate or in a jar. So the shape of the sugar particle is going to be same. So whether you are going to take it in your hand plate or whether you are going to keep it in oval jar or like the straightforward jar, wherever it is, you cannot change the shape of the sugar or the salt particle. Is it clear?
Yes.
Yes,
Yes.
ma'am.
Okay, good. So you will mark it in your book, okay? You are not going to write again. Next, what about a sponge? It is solid, yet we are able to compress it. As you told me that, ma'am, you cannot compress the sponge, like compress the solid material. But sponge, everybody knows the sponge, I guess. Yes, no,
Yes.
Yes.
right? You can easily, compress it, right? So how can you say it is a like? You can say it is a solid. So sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. So basically, this is a sponge. It has tiny particles, or you can say tiny holes over here. So air is filled. Okay, so when you are going to compress it, air is going to move out. Okay, air is expelled out, and because of that, it get compressed. So that's why sponge is also a solid material. Clear?
Yes, ma'am.
Yes.
Okay. So quickly you will read the questions as well as the answers on your own. And after that, I'll start with Lect. Because in exam hall, there are high chances you'll get the question that what about sponge? It is solid yet you can compress it, but it is the characteristics of solid that it is negligible compressibility. So how can you say that sponge is a solid one, or is it in solid state? So yeah, because of you should remember the reasons. Okay. Done, students.
Yeah. Yes.
So let's just the second one is liquid state. Okay. So liquid state we observe. Okay, I'll say this. Okay, liquid state. So now we observe that liquid has first no fixed shape, but they have fixed volume. Okay. So they take up the shape of the container in which they are kept. Liquid flow and change shape. So this is third. First, no fixed shape, but fixed volume. Liquid flow and change shape. So they are not rigid. They are not rigid. Okay. But can be called fluid. Okay. Clear? Fluid is basically they keeps on
Yes.
flowing. Right? Okay.
Mm.
Mm. Okay, so you are going to write second liquid. Then first no fixed shape, fixed volume, liquid flows, change shape, not rigid, and are called fluids. Done.
Yes.
Yes, ma'am.
Oh, so okay. Now I have a question for you people. Okay. For example, this is liquid and this is liquid. Liquid and liquid. Okay. And on the other hand, it is solid and liquid. If I'm going to diffuse them, diffuse means I'm going to intermix them. Okay. So which one will be easier or which one will be very quick? Liquid, liquid or solid liquid?
Liquid, liquid.
Okay. What about other?
Liquid, liquid.
Liquid and liquid.
Yes.
Okay. Why so? Any reason for that? So yes. Okay. Okay. So basically why? See, because you can see in liquids, for example, this is the intermolecular space and this is the intermolecular. But over solid, it will be like this. And okay, for liquid, it is going to be loose. So loose, they are going to, right? So rate of diffusion is always higher in liquid as compared to solids. That's why liquid will diffuse faster as compared to solid and liquid. Clear?
Yes,
Yes.
ma'am.
Right? Okay. So basically, this is what written over here. We'll just give it a quick reading. Like everything, I hope you are clear with this. So every time you have to go for the intermolecular space. Okay. So because if you have good space, only then I'm going to mix with you. If you don't have good space, how will I mix? Okay. So now the gas from the atmosphere diffuses and dissolves in water. The gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animal and plant. So basically what happens in water bodies also, like for example, this is a pond. Okay, here only like the oxygen get dissolved with water because oxygen is gas and liquid. So they quickly get dissolved. Diffusion takes place. Okay. And all living creatures need to breathe for survival. So they need oxygen, right? The aquatic animal can breathe underwater due to presence of dissolved oxygen in water. Okay, so you will write hashtag, or you can just write it with your black color or any other color. How aquatic animals breathe underwater. You'll write how aquatic animals breathe underwater. Question is how aquatic animals breathe underwater. So you're going to write like this: due to the presence of dissolved oxygen in water. Okay, due to the presence of, answer is due to the presence of dissolved oxygen in water. Because everybody needs oxygen, every living organism needs oxygen to breathe. So in water, see, it is like, for example, if I'll throw you in water, right? You people cannot, you people cannot breathe. Though you have oxygen in oxygen dissolved in water, but still you cannot breathe. Why? Because you don't have gills, right? But how are the plants or how the organism who are living inside or in the water, how they are doing that or how they are breathing? Because they are taking oxygen from water, because oxygen is being dissolved in water, and so from the water itself they are taking the oxygen, because oxygen is dissolved over there. Clear?
Yes.
Yes.
Okay, write it down and let me know once done.
Done, ma'am.
Okay,
Yeah,
Adil done?
yes.
Oh, okay. Now, this we can conclude that solid, liquid, and gas is diffuse into liquid. Okay, whether solid, whether liquid or gas, they can diffuse in liquids. The rate of diffusion of liquid is higher than that of solid. This is due to fact that in the liquid state, particles move freely and have greater space between each of them as compared to particles in the solid state. Okay, so you will write the question like this: that uh, diffusion will be faster in what? Diffusion, hashtag diffusion will be faster in what? In which state? So you can write liquid, liquid or solid, liquid. I don't know whether it's written in the notes. Okay. Or you can write which will mix faster, or you can write where diffusion will take place, liquid, liquid or liquid, solid, like this. Okay. And after that, you can write this answer that in liquid, liquid diffusion will be faster, or you have started writing, students?
No, ma'am.
No? Okay. So you can write the question like this: why liquid, liquid, why diffusion is faster in, just write it down, why diffusion is faster in liquid, liquid and slower in solid, liquid. Okay. Why diffusion is faster in liquid, liquid, okay, and slower in solid, liquid. Okay. And the answer will be, this is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to the particles in the solid state. Okay.
Done, ma'am.
I'm done.
So now the third state, which is gaseous state. Okay. So basically, this is something the theory portion. Okay. So basically, what are the qualities of gas? They are highly compressible. Okay. And next is mm, we have to find it out. Okay, because it's not written over here. They have high. They are highly compressible. Next, they are easy to. They have high intermolecular space. Right. They don't have any fixed shape and fixed volume, like fixed shape, or you can say rigid shape. Okay. So I'll just share the notes. You can write it over here. No fixed volume, no fixed shape, maximum intermolecular space, and the last point which was mentioned there, compressibility. Okay, just write it down. No fixed volume, gaseous state, no fixed volume, no fixed shape, maximum intermolecular space. Okay, and the next one will be highly compressible. Okay, I'm just writing highly compressible. Just don't write low attraction. That is something. Done.
Yes.
Jeba
Done,
done.
ma'am. Yes, ma'am.
Okay. So we'll just quickly give it a reading, like whatever written over here, right? We have observed that gas are highly compressible as compared to solid and liquid. Okay. The LPG cylinder that we get in our home for cooking or the oxygen supplied to the hospital in cylinder is compressed gas. Okay. Which is CNG and the LPG. I hope you people know the full form of CNG and LPG. So if not, you can write it down. What is the full form of CNG and LPG? Okay. Sometimes they ask you in one word or something like that. The liquefied petroleum gas and CNG, a compressed natural gas. Okay. So is used as fuel these days in vehicles. You know that CNG is used in vehicles. Due to why CNG is being used? Because it is highly compressible. That's why we are using CNG. Large volume of gas can be, for example, why you are using CNG in gas, why not petrol and all that? Because you can compress large amount of gas. So it's not like that. For example, if it is like this is a cylinder, you can compress as much gas like what according to the capacity of the cylinder. So that's why you are going to use CNG in your like CNG as a fuel. Okay. We come to know that what is being cooked in the kitchen without even entering there by the smell that we have already done, right? So the particles of aroma of food mixed with the particles of air spread from the kitchen reach us and even farther away. The smell of hot cooked food reaches us in seconds compared to this with the rate of diffusion of solid and liquid. Due to high speed of particles and the large space between them, gas shows the property of diffusing very fast into other gases. Okay. In the gaseous state, the particles move about randomly at high speed due to this random movement. The particles hit each other and also the wall of the container. The pressure exerted by the gas is because of this the force exerted by the gas particle per unit on the wall of the container. got it? Like whatever is written over here, we already discussed it, that the particles, what is happening basically, the cooked food, which is basically, the particles of food particles get mixed with the particles of air, and somewhere they reach us to you. Clear?
Yes.
Both of you?
Yes, ma'am.
Okay. So this is your homework. Like you have written CNG and LPG. This is your homework. You'll get you will give a reading for this. You'll read this paragraph, and next class I'll ask you few questions. Okay.
Okay, ma'am.
Okay. So you're going to answer me properly. Like I'm just giving you a hint. I can ask you the question why we use CNG. CNG in our vehicles as a fuel. I can ask you why you get the smell from the kitchen without entering air. I can ask you anything, so you should ready with your good answer. Okay,
Yes,
clear?
ma'am.
You should write it down like these questions and you'll answer it accordingly. Answer is written over here. So first question is why we use CNG as a fuel. You can write it down. Why we use CNG as a fuel? Right, leave 2 or 3 lines and after that write other question. Why we use CNG as a fuel? First question. And second one, how can how can we get to know what is being cooked in the kitchen without even entering there? How can we come to know that come to know of what is being cooked in the kitchen without even entering there? So these are the 2 questions homework. I hope you will be doing because I'll be asking you tomorrow. We'll have the next class, so tomorrow itself I'll ask you the answers. Either Adil will be answering question number second or question number first, or Jiba will be answering question number 1 or question number 2. Okay,
Yes, ma'am.
done, both of you?
Yes.
Yes, ma'am.
Do you want me to repeat the question, Adil?
No.
No? Okay. So just read it, and from tomorrow onwards, we'll discuss few questions, and then we are going to start with some change in matter like solid and all that, like how we convert solid into gas